Today we are going to discuss about green steel, a net zero carbon emissions. Carbon dioxide emissions from steel industry plays a vital role in global temperatures rise. Iron and steel production accounts for 7% of total global CO2 emissions, and climate and energy experts have long considered it one of the more challenging industries to decarbonize. Recycling of steel can mitigate some of the emissions, provided furnaces run on electricity from low or zero carbon sources, but will not suffice to meet global demand in the 21st century. Building all of the wind turbines, transmission towers and other infrastructure we need for global decarbonization will require a lot of steel. Additionally, growing economies in China, India and other rapidly developing nations are expected to drive a big increase in steel demand over the next few decades. Considering industrial growth, carbon emission will increase exponentially in near future, and if we do not take right measure to reduce carbon emissions, global temperature will rise by another 1.5 degrees centigrade by 2050 as per expert. We will discuss on the following topics in today's discussion. What is green steel? Facts and figures. Annual crude steel productions data. What is net zero CO2 emission target of India? What is CO2 emission target of India's top companies by 2030? What are the primary sources of CO2 generation in steel production? How to reduce CO2 emission during crude steel manufacturing? Traditional vs hydrogen and hybrid steelmaking. How to achieve zero carbon footprint. So, what is green steel? Steel with zero carbon emissions, but in current scenario, steel with the lowest carbon footprint currently possible. According to Forbes India, mentioned in an article that, in order to significantly reduce CO2 emissions during steel production, fossil fuels, especially coal, need to be replaced by green hydrogen, which is produced from renewable energy sources. Volkswagen plans to use this low-carbon, non-fossil fuel steel in major projects such as its upcoming Trinity electric sedan. Last year, Volvo and Mercedes-Benz announced that they too would soon use green steel in the production of their future models. This type of initiative will help significantly reduce the carbon footprint of these manufacturers, for whom sustainable development and the circular economy are now two key concepts. Some facts and figure. In this graph, one is showing carbon emission from fossil fuels and industry in billion tons by continents-wise and country-wise. Asia is the largest contributor of carbon emission in current decade, whereas China is the largest contributor. Along with India, Qatar, Saudi Arab and others fossil fuel producing countries are also parts of the carbon emission. In this graph we can see that carbon dioxide emission per capita and percent share of annual global emissions, percent of carbon dioxide emissions, are increasing for Asian countries and developing countries. So, if we calculate the cumulative contribution of carbon dioxide emissions from last 3 to 4 decades, United States are the greatest contributor followed by China. Human emissions of carbon dioxide and other greenhouse gases are a primary driver of climate change. We see that over the last few decades, global temperatures have risen sharply to approximately 0.7 degrees centigrade higher than our 1961 to 1990 baseline. When extended back to 1850, we see that temperatures then were a further 0.4 degrees centigrade colder than they were in our baseline. Overall, this would amount to an average temperature rise of 1.5 degrees centigrade. Only in past 40 years, average global temperature increased by 1 degree centigrade. Expected average global temperature increase of another 1.5 degrees Celsius by 2050 as per an expert. Emissions come from many sectors. It is clear from this breakdown that a range of sectors and processes contribute to global emissions. Let's walk through each of the sectors and subsectors in the pie chart one by one. Energy sector, electricity, heat and transport 73.2%. Out of which energy use in industry 24.2%, transport 16.2%. Energy use in buildings, 17.5%. Energy-related emissions from the manufacturing of iron and steel industry is 7.2%. Direct industrial processes, 5.2%. Waste, 3.2%. Agriculture, forestry and land use, 18.4%. So, if we look into the global annual production data of year 2021, China is the most crude steel producer globally, 1,032 million tons, followed by India, 118 million tons, and then Japan, United States, Russia, and so on. If we look into top 10 global companies, Tata Steel is at number 10, having production of 30.59 million tons of crude steel in the year 2021. And if we look into India's top 5 steel manufacturing company, Tata Steel having the largest manufacturer, followed by JSW Steel, Steel Authority of India, Jindal Steel and Power, and Vizag Steel. Tata Steel Group India has been produced 8.98% more than previous year 2020, whereas others companies are also gained production compared to year 2020, like JSW Steel 25%, Steel Authority of India 15%, Jindal Steel and Power 6%, and Vizag Steel 40%. India is planning to double its steel capacity to 300 million tons by 2030-31 as per Ministry of Steel, India. What is net zero CO2 emission target of India? India has promised to cut its emissions to net zero by 2070. Net zero, or becoming carbon neutral, means not adding to the amount of greenhouse gases in the atmosphere. China has announced plans for carbon neutrality by 2060, while the US and EU aim to hit net zero by 2050. India is the world's fourth biggest emitter of carbon dioxide, after China, the US, and the European Union. Indian steel companies to reduce emissions to 2.4 tons of CO2 per ton of crude steel output by 2030 from 2.6 tons in 2020. What are the CO2 emission target of India's top companies by 2030? Steel companies in India and their commitments to reduce CO2 emissions. 1. Tata Steel Limited production capacity 34 MTPA, million tons per annum. Tata Steel has a mission to bring down the carbon dioxide emissions to 1.8 tons of CO2 per ton of crude steel by 2030. 2. JSW Steel Limited production capacity 18 MTPA. JSW Steel has set a target of achieving CO2 emissions of 1.95 ton CO2 per ton of steel by fiscal 2030. 3. Steel Authority of India Limited SAIL production capacity 21 MTPA. While projecting CO2 emission of 2.2-2.4 ton per TCS tons per ton of crude steel in the blast furnace BOF route and 2.6 to 2.7 ton per TCS in DRI-EAF route by the terminal year 2030. SAIL has fixed up a target of 2.30 ton of CO2 emission per ton of crude steel production by 2030. 4. Jindal Steel and Power Limited, JSPL, production capacity 8.4 MTPA. JSPL has ESG objectives to be amongst the top 10 lowest CO2 emitting steel companies in the world. The firm aims to significantly reduce its carbon footprint by almost half as part of its ESG objective. What are the primary sources of CO2 generation in steel production? From the table it is found that CO2 sources for power generation are coal and fuel burning. CO2 sources for sintering or pelletizing are solid fuel, ignition gas, calcination etc. CO2 sources for coking are washed coal, oven heating fuel etc. CO2 sources for iron making are coke reduced iron process and hot blast stove. CO2 sources for steel making are molten iron decarburization, ladle and tundish heating fuel. CO2 sources for casting and rolling is heat treatment using fuel. How to reduce CO2 emission during crude steel manufacturing? 1. Use of green electrical energy. 2. Use of natural gas or biogas or green hydrogen as alternative of fuel. 3. Use of carbon filtration plant. Tata Steel recently commissioned the first plant in India that captures carbon dioxide from blast furnace emissions at its Jamshedpur site. 4. Increase share of scrap-based EAFs. 5. Reduction in use of hot metal from BF. 6. DRI and EAF using hydrogen. We can see from the process flow diagram that in conventional iron production, blast furnaces use coke, nearly pure carbon coal, to heat ore, and separate oxygen from the iron in the ore. For this step, hybrid uses a different, more efficient process called direct reduction. While this can be done with natural gas, or even coal, as the agent that removes the oxygen. Hybrid's innovation is to use hydrogen, made from electrolysis powered by renewable energy. Instead of soot from unburned carbon and large amounts of CO2, the hybrid plant emits clouds of water vapor. Most blast furnaces are linked to a basic oxygen steel plant, for which the hot metal typically contains 4 to 4.5% carbon. So, to avoid larger percent carbon contains in hot metal as steel melt shop input, we can replace with purely iron scrap and DRI, which to be melted through electric arc furnace instead of basic oxygen furnace. Recently, one news become very popular in social media that Tata Steel is staring at the prospect of shutting down its UK operations unless the British government steps in with a subsidy of about £1.5 billion, rupees 14,400 crore in the course of the next 12 months. The aid will help the company cut down on its carbon emissions. A report by the Financial Times (FT) states that Tata Steel, as part of its decarbonization bid, will close 2 blast furnaces at Port Talbot and build 2 electric arc furnaces, which will be less carbon intensive. However, the report adds that this will cost the company about £3 billion and that the company is hoping to receive half of that amount from the UK government in the form of a subsidy. Is it possible to achieve zero carbon footprint? Yes, it is possible to achieve zero carbon footprint in steel production. 1. By using green energy from renewable sources. 2. Use of hydrogen gas in DRI and electric arc furnace. 3. Purely scrap and recharging in electric arc furnace. 4. And use of carbon capturing from furnace gases. Thanks for watching. Hope you have understood the way forward, how to reduce carbon emission generates from iron and steel industry. Please like and subscribe for more videos on steel plant related process and automation.